According to the National Electrical Code, the following wiring methods are acceptable for commercial kitchens. Firstly, conduit. This includes rigid metal conduit, intermediate metal conduit, electrical metallic tubing, or flexible metal conduit with type MW wire. Secondly, cable, specifically type MC cable, also known as metal clad cable with type THHN or THWN wire. Understanding the difference between BX cable and MC cable is crucial. 12/2 BX cable is a non-metallic sheathed cable that typically contains two insulated conductors and a bare ground wire. It's often used in residential and light commercial applications. MC cable, on the other hand, is a metal jacketed cable that contains multiple insulated conductors and a bare ground wire. It's more durable and resistant to damage compared to BX cable. MC cable is recommended for commercial kitchens for several reasons. Firstly, increased durability. The metal jacket of MC cable protects the conductors from moisture, dust, and physical damage. This is particularly important in commercial kitchens where there's a lot of heat, humidity, and grease. Secondly, circuit integrity. The metal jacket provides a continuous electrical path and helps maintain circuit integrity in the event of a fault. Thirdly, resistance to heat. MC cable with type THHN or THWN wire is rated for higher temperatures compared to BX cable, making it suitable for use in hot environments. Given these factors, it's recommended to switch to MC cable for the remaining wiring in the commercial kitchen. It's more durable, resistant to damage, and compliant with electrical codes. While BX cable might be sufficient for some light commercial applications, MC cable is the preferred choice for the harsh conditions typically found in commercial kitchens. Let's delve into the specific types of conduit mentioned in the National Electrical Code, or NEC, as acceptable wiring methods for commercial kitchens. Rigid metal conduit, or RMC, is a heavy-duty, threaded tubing, typically made of galvanized steel. It offers excellent protection against physical damage and is suitable for both indoor and outdoor applications, as well as underground installations when properly coated to prevent corrosion. Intermediate metal conduit, or INC, is a thinner-walled version of RMC, making it lighter and easier to work with while still providing significant protection. Like RMC, IMC is also suitable for various applications, including those where mechanical protection is needed. Electrical metallic tubing, or IMD, is a lightweight, non-threaded tubing, often made of galvanized steel or aluminum. It's commonly used for indoor wiring in commercial and residential buildings. EMT is relatively easy to bend and cut, which makes it a popular choice for many electrical installations. However, it requires fittings to be secured to the tubing. Flexible metal conduit, or FMC, is a spiral wound, flexible steel or aluminum conduit. It's used in situations where flexibility is required, such as connecting to motors or other equipment that may vibrate or move. FMC provides mechanical protection, but is not watertight unless used with special fittings. Now let's focus on the wire types mentioned in conjunction with these conduits. Type MW wire is a single conductor wire insulated with moisture-resistant rubber. It is suitable for use in wet locations when installed in a conduit system. It has largely been replaced by more modern insulation types like THHN and THWN, but may still be encountered in older installations. Type THHN wire is a single conductor wire with thermoplastic high heat resistant nylon coating. It is one of the most commonly used types of building wire due to its versatility, high temperature rating of 90 degrees Celsius in dry locations, and resistance to moisture. Type THWN wire is similar to THHN but is also rated for wet locations. The W in THWN stands for water resistant. It can be used in conduit cable trays and other raceways in both dry and wet environments. When using MC cable, the NEC requires it to contain either THHN or THWN wire. These wire types provide the necessary insulation and temperature ratings required for commercial kitchen environments. Now let's compare the properties of THHN and THWN. THHN stands for thermoplastic high heat resistant nylon. THHN is a single conductor wire insulated with thermoplastic insulation and a nylon jacket. It is primarily used in dry locations, although it can be used in damp locations if it complies with certain requirements. THWN stands for thermoplastic heat and water-resistant nylon. THWN is also a single conductor wire with thermoplastic insulation and a nylon jacket, but it is specifically designed for use in both wet and dry locations. The key difference is the water resistance. THWN is suitable for use in conduit, underground, or in other wet environments, while THHN is generally not recommended for these applications unless it is specifically marked THHN/THWN-2, which indicates dual compliance. In a commercial kitchen, where moisture and humidity are common, THWN is often the preferred choice for wiring with an MC cable to ensure safety and longevity of the electrical system. Now let's consider the grounding requirements for electrical systems in commercial kitchens. Grounding is a critical safety measure that provides a low impedance path for fault current to return to the source, tripping the circuit breaker or fuse and preventing electrical shock hazards. In both BX and MC cable, a bare ground wire is typically included. This ground wire must be properly connected to the equipment grounding system to ensure effective grounding. The metal jacket of MC cable also contributes to the grounding system by providing a continuous conductive path. This is particularly important in commercial kitchens where there may be multiple pieces of metal equipment that need to be grounded. It's crucial to ensure that all metal parts of the electrical system, including conduit, cable trays, and equipment enclosures, are properly bonded together and connected to the grounding electrode system. This helps to minimize the risk of electrical shock and ensures the safe operation of electrical equipment. Let's elaborate on the specific benefits of using MC cable in commercial kitchens. Firstly, enhanced protection. The metal jacket of MC cable provides a robust barrier against physical damage, such as impacts from equipment, tools, or carts. This is especially important in busy commercial kitchens where accidents can happen. Secondly, resistance to chemicals and grease. Commercial kitchens often use strong cleaning chemicals and degreasers. The metal jacket of MC cable is resistant to these chemicals, preventing them from degrading the insulation of the conductors. Thirdly, fire resistance. MC cable is more fire resistant than non-metallic cables like BX cable. In the event of a fire, the metal jacket can help to contain the flames and prevent them from spreading quickly. Fourthly, compliance with codes. The National Electrical Code, or NEC, often requires or recommends the use of MC cable in commercial kitchens due to its superior safety and durability characteristics. By using MC cable, one can ensure compliance with local electrical codes and avoid potential fines or safety hazards. Fifthly, electromagnetic interference, or EMI, shielding. The metal jacket of MC cable provides shielding against electromagnetic interference, which can disrupt the operation of sensitive electronic equipment. This is becoming increasingly important as commercial kitchens incorporate more advanced technology, such as computerized ovens and control systems. Let's discuss the different types of fittings and connectors used with MC cable. Proper installation of MC cable requires the use of approved fittings and connectors to ensure a secure and reliable electrical connection. Firstly, MC cable connectors. These connectors are designed to securely clamp the MC cable to an electrical box or enclosure. They typically feature a screw-down mechanism that tightens around the metal jacket of the cable, providing a mechanical and electrical connection. Secondly, anti-short bushings or redheads. These small plastic bushings are inserted into the cut end of the MC cable to protect the conductors from abrasion against the sharp edges of the metal jacket. They are an essential component of a safe and code-compliant MC cable installation. Thirdly, grounding bushings. These bushings are used to provide a grounding connection between the MC cable and the electrical box or enclosure. They typically feature a screw or lug that can be connected to a grounding wire. Fourthly, weatherproof connectors. For outdoor or wet location installations, weatherproof connectors are used to prevent moisture from entering the electrical box or enclosure. These connectors typically feature a rubber gasket or seal that provides a watertight connection. Fifthly, cable ties and supports. Cable ties and supports are used to secure and support the MC cable along its run. This helps to prevent strain on the cable and ensures that it is properly supported. When selecting fittings and connectors for MC cable, it's important to choose products that are specifically listed and labeled for use with MC cable. This ensures that the fittings are compatible with the cable and that they meet the required safety standards. Now let's talk about the correct method for cutting and preparing MC cable for termination. Firstly, safety precautions. Before cutting MC cable, ensure the power is turned off to the circuit. Wear safety glasses and gloves to protect yourself from sharp edges and debris. Secondly, cutting the cable. Use a cable cutter or a hacksaw to cut the MC cable to the desired length. Be careful not to damage the conductors inside the cable. Thirdly, removing the armor. After cutting the cable, carefully remove the outer metal jacket, also known as armor, using a spiral cutting tool or a hacksaw. Screw the armor along the desired length and then bend the cable to snap the armor open. Fourthly, installing an anti-short bushing. After removing the armor, inspect the conductors for any damage. Install an anti-short bushing, often referred to as a red head, over the conductors to protect them from the sharp edges of the armor. Fifthly, stripping the conductors. Use a wire stripper to carefully remove the insulation from the ends of the conductors. Be sure to strip the correct amount of insulation to ensure a secure connection in the terminal or connector. Sixthly, terminating the conductors. Connect the conductors to the appropriate terminals or connectors, ensuring that they are securely tightened. Follow the manufacturer's instructions for the specific terminals or connectors being used. Remember, proper preparation of MC cable is essential for safe and reliable electrical connection. Now, let's consider the importance of proper support and spacing for MC cable runs. Proper support and spacing of MC cable are crucial for ensuring the long-term reliability and safety of the electrical system. The National Electrical Code, or NEC, provides guidelines for supporting and spacing cables to prevent damage and maintain proper airflow. Firstly, support requirements. MC cable must be supported at intervals not exceeding 6 feet or approximately 1.8 meters. Shorter intervals may be required in certain situations, such as when the cable is subject to physical damage or installed in a vertical room. Secondly, support methods. Acceptable methods for supporting MC cable include cable ties, straps, and hangers. These supports should be designed to securely hold the cable without damaging the outer jacket or conductors. Thirdly, spacing requirements. MC cable should be installed with sufficient spacing between other cables, conduits, and equipment to allow for proper airflow and prevent overheating. The NEC specifies minimum spacing requirements for different types of cables and conduits. Fourthly, protection from physical damage. MC cable should be protected from physical damage by installing it in a location where it is not likely to be struck or damaged. If the cable is exposed to physical damage, it should be protected by conduit or other means. Fifthly, avoiding strain. When installing MC cable, avoid creating excessive strain on the cable by bending it sharply or pulling it too tightly. Use gradual bends and provide sufficient slack to prevent stress on the conductors and terminations. By following these guidelines, the integrity of the MC cable installation can be maintained and the risk of electrical problems can be minimized. Now, let's review some common mistakes to avoid when working with MC cable. Firstly, improper cutting of the armor. Cutting the armor of MC cable incorrectly can damage the conductors inside, leading to shorts or other electrical problems. Always use a proper cable cutter or hacksaw and be careful not to cut too deeply. Secondly, failure to install anti-short bushings. Anti-short bushings are essential for protecting the conductors from the sharp edges of the armor. Failing to install these bushings can result in damaged insulation and potential electrical hazards. Thirdly, over-tightening connectors. Over-tightening MC cable connectors can damage the cable and compromise the connection. Tighten the connectors only to the manufacturer's specified torque. Fourthly, using incorrect fittings. Using fittings that are not specifically designed for MC cable can result in a poor connection and potential safety hazards. Always use fittings that are listed and labeled for use with MC cable. Fifthly, exceeding bend radius. Exceeding the minimum bend radius of MC cable can damage the cable and reduce its current carrying capacity. Follow the manufacturer's recommendations for bend radius. Sixthly, improper grounding. Improper grounding of MC cable can create a shock hazard. Ensure that the cable is properly grounded according to the National Electrical Code, or NEC. Seventhly, neglecting support requirements. Neglecting to properly support MC cable can lead to sagging, strain, and potential damage. Support the cable at the intervals specified in the NEC. By avoiding these common mistakes, a safe and reliable MC cable installation can be ensured. Now, let's discuss the types of electrical boxes and enclosures that are suitable for use with MC cable in commercial kitchens. Electrical boxes and enclosures serve as protective housings for electrical connections, splices, and devices. They provide a safe and secure environment for electrical components and help to prevent electrical shock hazards. Firstly, metal boxes. Metal boxes, such as steel or aluminum boxes, are commonly used with MC cable due to their durability and grounding capabilities. They provide a robust enclosure for electrical connections and help to maintain circuit integrity. Secondly, non-metallic boxes. Non-metallic boxes, such as plastic or fiberglass boxes, can also be used with MC cable in certain applications. However, they must be properly grounded using a grounding wire or other means. Thirdly, surface-mounted boxes. Surface-mounted boxes are mounted directly on the surface of a wall or ceiling. They are typically used when it is not possible or practical to recess the box into the wall. Fourthly, recess boxes. Recess boxes are installed inside the wall or ceiling, providing a flush appearance. They are commonly used for switches, receptacles, and other devices that are mounted flush with the wall. Fifthly, weatherproof boxes. Weatherproof boxes are designed to protect electrical connections from moisture and other environmental factors. They are typically used in outdoor or wet locations, such as commercial kitchens where water and humidity are present. When selecting electrical boxes and enclosures for use with MC cable, it's important to choose products that are listed and labeled for the intended application. This ensures that the boxes are compatible with the cable and that they meet the required safety standards. Let's shift our focus to the topic of ampacity and conductor sizing for MC cable in commercial kitchens. Ampacity refers to the maximum amount of electrical current, measured in amps, that a conductor can safely carry without exceeding its temperature rating. Proper conductor sizing is essential for preventing overheating, voltage drop, and other electrical problems. The National Electrical Code, or NEC, provides guidelines for determining the appropriate conductor size based on the ampacity of the circuit and the type of wire used. Firstly, ampacity tables. The NEC contains ampacity tables that list the allowable ampacities for different types of conductors based on their size, insulation type, and temperature rating. These tables should be consulted to determine the appropriate conductor size for a given circuit. Secondly, derating factors. In certain situations, it may be necessary to derate the ampacity of a conductor due to factors such as high ambient temperatures, multiple conductors in a raceway, or continuous operation. Derating factors are applied to the ampacity values listed in the NEC tables to account for these conditions. Thirdly, voltage drop. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to operate inefficiently or malfunction. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. Fourthly, conductor size calculation. To determine the appropriate conductor size for circuit, one must calculate the total load on the circuit, apply any necessary derating factors, and then select a conductor size that has an ampacity equal to or greater than the calculated load. Fifthly, THHN and THWN ampacity. THHN and THWN conductors, commonly used in MC cable, have different ampacity ratings depending on the temperature rating of the terminals to which they are connected. The NEC specifies the allowable ampacities for these conductors at different temperature ratings. By following these guidelines and consulting the NEC, one can ensure that the conductors and MC cable are properly sized for the intended application and that the electrical system operates safely and reliably. Now, let's explore the topic of overcurrent protection for circuits using MC cable in commercial kitchens. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting electrical circuits from overloads and short circuits. These devices are designed to interrupt the flow of current when it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. Firstly, circuit breakers. Circuit breakers are electromechanical devices that automatically trip and interrupt the flow of current when an overcurrent condition occurs. They can be reset manually after the fault has been cleared. Secondly, fuses. Fuses are one-time devices that contain a fusible link that melts and interrupts the flow of current when an overcurrent condition occurs. Fuses must be replaced after they have blown. Thirdly, sizing overcurrent protection. The National Electrical Code, or NEC, provides guidelines for sizing overcurrent protection devices based on the ampacity of the circuit and the type of equipment being protected. The overcurrent protection device should be sized to protect the conductors from overheating without causing nuisance tripping. Fourthly, coordination. Coordination refers to the selective tripping of overcurrent protection devices in a series. The goal of coordination is to ensure that only the overcurrent protection device closest to the fault trips, minimizing the disruption to the rest of the electrical system. Fifthly, arc fault circuit interrupters, or size. ASIs are special types of circuit breakers that are designed to detect arc faults, which are dangerous electrical arcs that can cause fires. The NEC requires ASIs to be installed in certain circuits in residential and commercial buildings, including some circuits in commercial kitchens. Sixthly, ground fault circuit interrupters, or GFCIs. GFCIs are devices that are designed to detect ground faults, which are electrical faults that occur when current flows to ground through an unintended path. The NEC requires GFCIs to be installed in certain locations where there is a high risk of electrical shock, such as in kitchens and bathrooms. By following these guidelines and consulting the NEC, one can ensure that the circuits using MC cable are properly protected from overcurrent conditions and that the electrical system operates safely. Let's now discuss the specific requirements for wiring appliances and equipment in commercial kitchens using MC cable. Commercial kitchens contain a variety of appliances and equipment that require electrical connections, such as ovens, ranges, refrigerators, dishwashers, and ventilation systems. It's essential to follow the manufacturer's instructions and the National Electrical Code, or NEC, when wiring these appliances to ensure safe and reliable operation. Firstly, dedicated circuits. Many commercial kitchen appliances require dedicated circuits to provide sufficient power and prevent overloading the electrical system. A dedicated circuit is a circuit that serves only one appliance or piece of equipment. Secondly, disconnecting means. The NEC requires a disconnecting means to be provided within sight of each appliance to allow for safe maintenance and repair. The disconnecting means can be a circuit breaker, a switch, or a plug-in receptacle. Thirdly, flexible cords. Flexible cords are often used to connect appliances to the electrical system. The cords must be of the appropriate size and type for the appliance and must be protected from damage. Fourthly, strain relief. Strain relief devices are used to prevent strain on the electrical connections at the appliance and at the electrical box. These devices help to ensure that the connections remain secure and prevent damage to the wiring. Fifthly, grounding. All appliances and equipment must be properly grounded to prevent electrical shock hazards. The grounding conductor must be connected to the appliance's grounding terminal and to the building's grounding system. Sixthly, wiring methods. MC cable is a common wiring method for connecting appliances and equipment in commercial kitchens. The cable must be properly supported and protected from damage. By following these requirements and consulting the manufacturer's instructions and the NEC, one can ensure that appliances and equipment in commercial kitchens are wired safely and correctly. Let's move to the subject of inspections and compliance for electrical installations using MC cable in commercial kitchens. Electrical inspections are conducted by qualified electrical inspectors to ensure that electrical installations comply with the National Electrical Code, or NEC, and local electrical codes. These inspections help to identify potential hazards and ensure that the electrical system is safe and reliable. Firstly, permit requirements. Most electrical installations require an electrical permit from the local building department. The permit application typically includes detailed plans and specifications for the electrical work. Secondly, inspection process. During the inspection, the electrical inspector will examine the electrical installation to ensure that it complies with the NEC and local electrical codes. The inspector may check the wiring methods, conductor sizes, overcurrent protection, grounding, and other aspects of the electrical system. Thirdly, common violations. Common electrical code violations include improper wiring methods, undersized conductors, inadequate grounding, and lack of overcurrent protection. These violations must be corrected before the electrical installation can be approved. Fourthly, compliance. To ensure compliance with electrical codes, it's important to hire a licensed electrical contractor who is familiar with NEC and local electrical codes. The contractor should obtain the necessary permits and ensure that the electrical installation is inspected and approved. Fifthly, documentation. It's important to maintain documentation of the electrical installation, including permits, inspection reports, and wiring diagrams. This documentation can be helpful for future maintenance and repairs. By following these steps, one can ensure that electrical installations using MC cable in commercial kitchens comply with electrical codes and are safe and reliable. Finally, let's summarize the key points regarding the use of MC cable in commercial kitchens. Firstly, MC cable is the preferred wiring method. MC cable is generally the preferred wiring method for commercial kitchens due to its durability, resistance to damage, and compliance with electrical codes. Secondly, NEC compliance. All electrical installations must comply with the National Electrical Code, or NEC, and local electrical codes. Thirdly, proper installation. Proper installation of MC cable is essential for ensuring a safe and reliable electrical system. This includes proper cutting, stripping, termination, support, and grounding of the cable. Fourthly, conductor sizing and overcurrent protection. Conductor sizing and overcurrent protection must be properly selected to prevent overheating, voltage drop, and electrical hazards. Fifthly, inspections. Electrical inspections are required to ensure that electrical installations comply with the NEC and local electrical codes. Sixthly, safety. Safety is the top priority when working with electricity. Always follow safe work practices and consult with a qualified electrician if needed. By following these key points, one can ensure that MC cable is used safely and effectively in commercial kitchens.